Welcome Mary Wickett and Mike Reynolds from WItt Limited Energy, and they're going to talk about the WItt energy harvesting, transmission, collecting, power from all sea motion. Mary and Mike. The floor is yours. The clicker is right there on the shelf.
Amazing video clip. I must have a very dirty mind because that's not what I thought they were doing. Good afternoon. Imagine if it was actually possible to collect any natural occurring motional energy and turn it into usable power. Natural occurring motional energy is all around us. It's in water, wind, human, animal, and vehicle motion. As I'm sure you all know, over 70% of the Earth's surface is water. This is an abundance of energy in the sea. Imagine capturing the power from our oceans. It will change people's lives for the better. It will provide power to enhance lives, bring new jobs and industry throughout the world, including remote and difficult-to-reach locations, bringing green energy to inhospitable locations with no adverse impact. Imagine collecting all that energy in a sealed, quiet unit and turning it into usable power in these harsh and corrosive conditions with no detrimental impact on the environment. As far as we know, no commercial solution exists. Imagine being able to build a device from inches or less to massive, huge, from tried and tested industry standard off-the-shelf components. It's a lot to ask. Now, let's think about the 30% of the planet where we all live. There is natural occurring energy everywhere. Imagine harvesting the energy from walking to charge your personal appliance. Think about collecting power from animal motion, a device that will collect power for GPS tracking, especially endangered species. Also, imagine a way to collect power in a rough terrain vehicle, they got it, for power needs, especially in the defense sector. This is just one suggestion. Imagine. Well, we've got some very good news. You don't have to imagine. We have a solution, the WItt. In 2009, Martin Wickett, one of the founders, an engineer who loves solving problems, took himself off to his workshop. After months and months of work, he came to terms with the mechanics of the concept and built and tested the first WItt transmission. He continued work on the design and testing, and finally a WItt transmission was connected to a small lamp. It worked. We had the eureka moment. Ladies and gentlemen, I present the WItt. So exactly what is the WItt? The WItt is a transmission system. The WItt stands for whatever input to torsion transfer, and is capable of collecting all chaotic motion, back and forth, up and down, side to side, all motion. It works on the same principle as the self-winding watch, except it does much more. It's affordable, it's a transmission, and mass-produced will be the equivalent cost of any gearbox of a similar size. We intend to design it like a standard car transmission, which requires no servicing in its lifetime. I expect you think these are big claims. Yes, they are. So let me take a minute or two to explain what it is and what it's actually capable of doing. WItt built a small prototype. We affectionately call this our boardroom demonstrator. And at the end of 2012, we connected it to a large, rather funky lamp. And as you will see from the video clip, the motion activates the pendulum and turns the flywheel in one direction as an energy harvesting unit. We took this opportunity to attach an off-the-shelf generator to the WItt system and light up this neon lamp. This needed 4 watts of power to start up, and therefore is a much better example than LED lighting, which, as I'm sure you all know, takes very little power. It was a good experiment, the principle being the heavier the pendulums, the more power that you can collect. The boardroom demonstrator in this film has a 2-pound pendulum. WItt has built the first power capturing device that takes chaotic motion and turns it into usable power. It is scalable from tiny, collecting fractions of a watt, to a system capable of delivering kilowatts and potentially megawatts. WItt can harvest energy to produce power for multiple applications. WItt offers a solution in green energy harvesting. Now, let's take a minute to look at the marine environment. A WItt sealed unit is an ideal vessel for energy harvesting in water, sea, river, and tidal, offering a robust solution and with good design, little to no maintenance. Our next video clip is a larger WItt proof of concept, where we fitted this inside a 4-foot sealed sphere and tested its reaction in 4-inch waves. The test prototype has a 44-pound pendulum and a 22-pound flywheel. And as you can see from the video clip, the wave motion activates the pendulum and turns the flywheel continuously. By the way, we have our logo on the flywheel, but sorry, it's going too fast to read. The test was conducted at Plymouth University's unit in the United Kingdom in their new £30 million state-of-the-art wave tank. Please note that there are no external moving parts. This ensures total safety for all marine life. The robust sealed unit should ensure long life, thereby reducing the costly overheads of replacing batteries and the costly servicing that this entails. There are no hazardous chemicals used in its construction, and even better, no emissions whatsoever. And it's totally recyclable. Using mathematical modelling, Glasgow University mechanical engineers produced the first projected power graphs, an example of which you can see on this slide. The modelling was applied to a number of different size systems. In July 2012, WItt received investment of $155,000 from a group of small investors based in the West Country. Most of them had never invested in a company before, but they all got it. They are passionate about the environment, and they wanted to do something that would make a difference and to help us advance the WItt to commercialization. WItt then received match funding from the European Clean Technology Co-Investment Fund. A patent has been granted in the UK and Europe, and a follow-on patent has been filed, ensuring global protection for the next 30 months. Of course, patent protection and new patents will follow. We feel we have built the basic Ford Model T. As an R&D IP business, our goal is to license the technology, and this is a perfect opportunity to raise awareness. This year, WItt has been successful in achieving 2 UK grant awards, the first was to fit the WItt inside a new design autonomous ocean vessel to collect pitch and roll motion for power and to run onboard data gathering equipment. The second award is a much sought after award and very difficult to win, as it is open to all industry. This award is through the Technology Strategy Board and is for vessel efficiency. This Fast Track Award is the first of its kind in the United Kingdom and is targeted at technologies that have the potential to reduce fuel consumption on vessels. The WItt team put together a strong consortium for this award, and work commenced just 12 weeks ago. Now, please don't take my word for it. May I now take the opportunity to introduce Mike Reynolds, lead partner in our consortium.
Good afternoon. I'm Mike Reynolds, Port Operations Director at the AMP Group. I represent the WItt Consortium that has been brought together to research the possibility of the WItt providing a power source to reduce fuel consumption on ships of over 500 gross tons. We are funded by private and public funding totaling $470,000. There are 5 organisations in the consortium. WItt, providing their patented technology and intellectual property and know-how. The AMP Group, a ship repair conversion, marine services, and marine renewable company, who are the lead of the project and provide knowledge of ocean-going vessels and how the WItt could be incorporated into ship systems. Supercat, an established engineering and design house that operates in the fields of marine, defence, oil and gas, and the renewable energy sector, working with WItt on design and build of a pre-production transmission system. And last but not least, 2 British universities, Plymouth and Exeter, who are researching ship motion characteristics and will be testing the WItt. The 10-month project covers the design, stress analysis, build and test of a WItt transmission system. For this project, 1 WItt transmission will be built measuring 1 foot 6 inches by 1 foot 6 inches by 8 inches deep. The WItt transmission will be tested on a specialised test facility designed and built by Exeter University called the DMAC, which is capable of simulating pitch and roll motion. A series of tests will commence in November this year and will continue for several months. The power output of the WItt will be measured when subjected to different forms of motion. From the results, lookup tables will be created that will be a clear indication of the likely power output of the WItt. And this will then be scaled up to predict the likely output for larger WItt devices and their reaction to motion created by a vessel at sea. The consortium will share the results with shipping companies to see if the power is usable to supplement or replace some of their onboard generating systems. We will also share this information with the UK government's Ministry of Defence to see how the WItt may be used by the Royal Navy. The UK government has stated that a 1 pence per litre increase in shipping fuel costs will cost the government in excess of $22 million per year. Reducing the use of fossil fuels is clearly a global problem, and the United States government and other governments are clearly also seeking a solution, but on a much larger scale. This is a good step forward in advancing the technology and bringing it closer to commercialization, not only in shipping, but also other sectors.
The project Mike has just described is just one of the applications the WItt could be used in. Many different organisations are interested in our technology. In marine alone, for example, data gathering buoys, buoys as we see in the UK, aquaculture, vessel efficiency, safety, and utility lighting. The WItt could also provide solutions for new ventures, ideal for marine parks, protecting all life, providing power for monitoring, tracking, surveillance, long-term studies. Global warming is just one example. Another example, collecting sea motion to power desalination units, providing clean water in remote locations. There are millions of people that do not have access to clean drinking water. Also, power needs for monitoring conditions prior to the installations of offshore wind turbines. This is to name just a few. Other uses for the WItt, they just need your imagination. WItt Energy is engaging with many other companies. Several months ago, Plymouth Marine Laboratory asked us to make a presentation. Their CEO, Professor Steve DeMora, is enthusiastic about the power solutions we could provide, and he recommended that we apply for this award. Thank you, Steve. Professor DeMora has kindly given permission for a WItt to be fitted in their data gathering buoy for long-term testing in UK coastal waters. WItt, as an IP business, needs funds to continue to protect the patent and advancing the technology, ensuring that we are in a strong position with a view to licensing or co-developing our technology. The WItt journey has been steady and progressive over the last 5 years. We have achieved an awful lot on a very tight budget, just under $500,000. Firstly, we needed confirmation from academia. WItt engaged with Scottish Enterprise, the Scottish part of the UK government, and we achieved 2 small first step awards. We embarked on working with Glasgow's University's School of Mechanical Engineering, and they are experts in the field of non-linear dynamics. They produced a 38-page feasibility report. Glasgow University then conducted an extensive 55-page marketing study. This body of work took 1 year and confirmed the WItt technology was capable of collecting chaotic motion and turning it into usable power. And for the techies in the audience, that means all 6 degrees. Imagine, please, all the potential this technology can actually have. WItt is an R&D business with a unique intellectual property, and we are now at technology readiness level 6, a UK term, but it means past prototype and very close to commercialization. We already have patent protection in the UK, Europe, China, and a follow-on patent has just been filed, ensuring patent protection globally. We have started to engage with industry, and as you have heard from this one application today that our consortium is working on, but we are now actively seeking more partners in the marine environment. We are now ready to speak to license or co-develop. WItt has been making amazing progress in the United Kingdom, which is fantastic, but we have always aimed high, and we've always thought big. From day one, we knew the WItt energy harvesting unit had global potential. But how could we make this happen? When WItt received details of this organization's award and your goals, we felt this opportunity was manna from heaven. This award would bring WItt to the world stage, open the doors to really getting on with the task at hand. WITs of all sizes collecting free energy that is all around us and doing something really worthwhile. If we won the award, WIT would be able to fast-track the build of a pre-production unit suitable for a data gathering buoy, which would be tested over months and provide real live data. Providing a power solution in the vast array of applications will help in more ways than we can imagine, bringing much-needed jobs to many different sectors and geographies, and solving energy problems and helping towards regenerating economies and reducing carbon emissions. WItt as a team feel the same as Ocean Exchange and your vision. Your worldwide network will make this happen. It is true, collectively, we can accomplish more. Your contacts, your skills can make this quantum leap, with the founders of the WItt as the ambassadors. It is now the right time to engage with like-minded people and organizations with one goal in mind, an energy solution to help all aspects of ocean health and safety. WItt would like to thank you for this amazing opportunity. We believe we are bringing to your attention a new technology with global potential. You are the experts in this field. Together, we could fast-track an ocean solution in a vast, vast range of power needs. We want to work with the right organizations that are passionate about our planet and oceans. My name is Mary Wickett, Managing Director of WItt, and Mike Reynolds, our lead in the consortium. We would like Martin Wickett to join us, the inspiration and the brains behind the WItt.
Thank you. Do you hear? Is he coming up? I think they'd like you to come on stage, sir. So we have a few questions time, a little bit of time for questions. A little bit shorter time for them than the others.
Oh, yes,
We're running short on time. Any questions? Dr. Chris Barnes, good to see you again. If you please just step up and to our microphone.
Yes, I'm Chris Barnes. I'm a professor of electrical and computer engineering at Georgia Tech. I have a question about the frequency response of the device. I saw the word tune in the presentation. Does the pendulum weight have to be matched to the expected frequency of the input vibration that it's trying to capture?
I think we'll have to get the technical person to answer this.
Yeah, absolutely. The length of the pendulum has to be tuned to the vessel that it's situated in, either at a fundamental or at a harmonic of the vessel.
So is that driven by the platform it's on, or the waves and the vibrations are trying to be captured?
It'll be the platform it's on. The waves are going to be the primary source of the input. The platform will be a secondary motion, and it will have its natural frequency, and the WItt will capture the energy from the platform.
How broadband is the device? Does it only operate in the narrow band that it's tuned towards, or does it give you a response or a wide frequency of inputs?
It's actually set up so that it works as a conical pendulum rather than a planar pendulum, so therefore you're not only talking about constructive and destructive interference, you're talking about vectors. So there is a wider range than for a planar pendulum.
Okay, thank you.
We'll make sure Chris asks all of our people questions. Good questions, Chris. Yes, sir.
Great presentation. I understand that you guys are still quantifying the real-world applications of this, but I would just like to know if you could tell us how big would a megawatt-size WItt be?
You got me there. Very good question. Basically, when you're looking at a mechanical situation, you've got limitations for gears. So it really depends on the vessel that it's in and the speed of the gears. But you would be looking at gears for a megawatt of at least 1.5 meters, sorry, 5 feet in your terms.
It should also be built in hydraulics. If you're building bigger, the actual patent covers not only just gears, but it could also be in hydraulics. So you could actually just build it as big as you wanted. And because it's a sealed unit, it should actually be totally safe in the environment and therefore be in the harshest conditions. it would be a transmission in a sealed unit.
Yes, ma'am.
Is this on? Okay.
Yes.
I'm Courtney. I'm with the Viral Video Intern team. You're welcome. So forgive me if this goes without saying, but does it work in conjunction with batteries so that certain objects, because it is scalable, when they're at rest, it would run on battery, and then when they're in motion, could run off WIT?
Absolutely.
Question.
Having a storage system would enhance the whole thing, and it could be used in dual with solar or whatever combination. Certainly in the northern hemisphere, in higher latitudes, they have problems with solar panels. So therefore, actually having something that's stimulated by the movement of the ocean would be an absolute boon for it.
Very good. I think we have time for another quick one, if there is one. Sure. Please.
That was a great question, because I was thinking the same thing. I didn't see an electrical cord coming out, or how do you get the power out of the speaker?
Basically, what we've done at the minute is we've actually totally concentrated on the patent and the building of some prototypes. And that's taken X amount of time, but that was our priority. We are totally aware that there's lots and lots of generators out there. We took an off-the-shelf generator and connected it to the WIT to light that rather large funky lamp, and that was with 2 pounds of pendulum. So basically there's plenty of generating company out there, and there's plenty of very, very clever battery companies that now batteries have become so efficient. So the WIT could actually be the stimulus of collecting all of that energy and storing or constantly topping up batteries. For example, if it was a very small egg-size unit, as if it was on your key fob, as you walked about, all of your motion just from walking would charge up enough power for your mobile phone or personal appliances. So it's got this massive range of scope, but batteries are very, very high now in efficiency. So we would just use that as a storage.
Okay, one more.
If you short it out, does it act like a 3D stabilizer?
Oh, that's a good one.
Oh my God.
Chris, you got any? No.
It really only works in one direction. Works input to output. You can't reverse it because the system is requiring the fact that there is motion and there is freewheeling in the system. So basically only works as an input device. If that
Very good.
answers your question.
There will be much more time to talk to them afterwards. Another round of applause for WIT Energy. Thank you, very good. Good job. Good job.